Hi, my name's Ben Zaitlin. I work at CRLT at Indiana University with Professor Kylie Pepler. And what I wanted to demonstrate today is this game that we built for children to learn about complexity theory. Professor Joshua Danish and Kylie Pepler are interested in teaching kids about complexity theory through interactive play. So what we have here is this bee that we built that has the LilyPad electronics platform embedded inside of the bee, inside here. And we have LEDs here to sort of help display some relevant information. So the first thing you'll notice is that this RGB LED is changing from green to orange, yellow to red. And this represents the energy that the bee has to actually go out and find nectar. If you don't find nectar and dump it into the hive in an appropriate amount of time, you die. So right now the bee is dead and has to be sort of recharged. The other thing that happens is the bee can sort of download nectar. And the way it does that is it touches a flower that has a embedded resistor. And using a voltage divider trick, we can measure the resistance, or actually measure the voltage, communicate wirelessly back with a computer, and have that unique voltage map to a unique flower identification. So when I actually touch a flower, what happens is that if the flower has nectar, I will download nectar, and this LED array represents how much nectar is currently on the bee. And even though there's 3 LEDs, I can hold more than 3 units of nectar. And the other set of LEDs here on the right side of my hand represent how much nectar is inside of the flower. So when an actual bee goes out and searches for nectar, it not only collects nectar from the flower, but it also determines how much nectar is left inside and whether or not it's of good quality. And then it eventually relays that information back to other bees inside of the hive. So if there's a lot of nectar in a flower or in a flower patch and it's of good quality, then eventually what you'll see is all of the bees traveling to that flower. So this is sort of like where the complexity happens, is because you have sort of autonomous bees, and you're trying to pass a lot of pass information to all these autonomous creatures. So I was going to demonstrate how this works. So the first thing I should do is probably reset this, just so that way I have some energy. All right, and here I go and touch this flower. So I touch the flower, and I pause for a second, and I downloaded some nectar, and I have 3 units of nectar left in this flower, so I can come back to it again if I want to. And now I have 2 units of nectar, and there's 2 units left in this other flower. Let's try another flower. So this one is flower 4. So here I'm downloading some nectar, and if you see on the screen, flower 4 correctly maps. And then what I do before the timer runs out, I dump this in the hive, and this hexagon sort of represents the hive. And now my web page hopefully will update well, if you see here, the light is blinking, which means that I have to sleep. We wanted to create a system that allowed the kids to change the bee in an appropriate amount of time. They weren't just always running around. So after this resets, the hive on that web page will increase its level. Thank you very much. I'll see you later.